Hello people, welcome back to another video in our entire Linux playlist. So today I'm going to be talking about processes, what they are, and how you can manipulate what the processes are doing, how you can manipulate their state. Now, whether you're a system administrator or you're a developer, it's crucial to understand what processes are and how do they actually function within your system itself. So today we're going to explore all about the processes. Let's get started. So first, before we move on to anything concrete, let's try and understand what exactly is a process. A process is simply an active instance of some running application. Now, I know that's a little confusing to understand, so let's just take an example. Now, imagine that you're running something like Google Chrome. How is it actually running? What's happening behind the scenes? Behind the scenes, Chrome is just running as a process. Now, the process is not alone. Chrome will have one parent process, and under that, it will have multiple child processes as well. And all of them will be responsible for doing something. It will all be doing different things, but that's the general rule. You have a parent process, which is the actual application. Then the application needs to do multiple different things. Could be data retrieval, could be running some piece of code or anything like that. So all those tasks will be assigned to sub processes within the same parent. So these sub processes are what we called as child processes. To understand what is a process is simply the running instance of an application which is doing something. Now there will be some amount of CPU resources and some amount of memory resources allocated to every single one of these processes. So today I'm going to show you how to actually play around with these processes and how to take a look at all of these processes. Before I go into the terminal and actually show you all these things live, hands-on, I want to talk about the three types of processes which exist within Linux. Number one, I just talked about them, which is your parent and child processes, right? I explained what it is as well. You have one parent process, and underneath that parent, you have multiple sub processes or child processes. The second type of process is called as a zombie or an orphan process. Now, an orphan process, or rather a zombie process, is just a particular process that has finished its work and it's still existing. This process needs to be deleted or it needs to be removed from our process table, but for some reason it still exists over there. Now imagine this. You have Chrome running as your parent process, and let's say you try to go to YouTube. So that will be another process, right? Now your browser, it has already landed on YouTube and you are at YouTube. The job which this child process has is completed. Now this parent process needs to understand that this child process, which was tasked for going to YouTube, has completed its execution, and then the parent is supposed to delete this child process. But now for some reason it could happen that the child process doesn't give out the proper signal, or the parent process doesn't receive the proper signal that this process has completed its execution and should be deleted. So that's when you have this zombie process that gets created. Now zombie processes can be created because of some other reason as well. It could be possible that you delete the parent and all of the child processes are just waiting for getting deleted. But since the parent is deleted, there's no one to actually send the signal to the child processes, right? So in that case, you would have to manually delete all of the processes. And yeah, these zombie processes are either intentionally created or unintentionally. I just gave you the scenarios for how it's created both intentionally as well as unintentionally. Now the final type of process which I want to talk about is called as a daemon. Now daemons are just a background process. But the key difference between a normal background process and a daemon is that daemons are usually something related to your system. So for example, in Linux, you have something called as systemd, What is systemd? I will touch a little bit about that over to the end of this video, so stay tuned for that. But systemd is something which is a system related process. So this is usually going to run as a daemon within your system. Look at something like Docker. Now, Docker is a container creation system. It's something to manage your containers. Don't worry about the technicalities. Just know that Docker has something called as a Docker daemon. So this Docker daemon, it has got the root privileges. It's got elevated privileges to run on your system. And this process of Docker, it runs as a daemon. All right, so I think that's enough theory. I think you have a good idea about what are processes and the different types of processes. Now let's go hop into a terminal and actually do some hands-on and have some fun with our processes. So here I am inside my terminal, and the first thing which I want to do is visualize all of the active processes that are running on my system right now. So for that, I can do a simple PS. Now PS is just going to give me a list of all the processes which are currently running in my session. So I like to remember PS as just a process, a short form for process. Let's go ahead and enter this and see what all processes are running. So here you can see that I have a total of 4 processes. Let's just go over what some of these indications refer to. Now first we have a PID. PID is simply a process ID. Take this for example, this first line. The process which is running is Zish, and the process ID which is assigned to Zish is 170. All right. Next we have the TTY. The TTY simply refers to which instance of the terminal is this particular process running on. Then the time. The time refers to the CPU time. So how long does the CPU actually require for running this particular process? Now, the second way which I want to show you to visualize all your processes is a command called as top. So top is simply going to give me a list of every single process which is running. It's going to show me which user is running that particular process, and it's going to show me what the process is as well. So right here, this is the menu of top. Now the first one itself, the user is a root, the process ID is 1. Now what is this PR and NI? PR is basically the priority of the process. So within your kernel, you have some sort of scheduling features which decides which process should be given a priority for running, right? So that priority number is just assigned to the process, which determines its priority for running. The second one, which is NI, is just something that is called as a niceness value. The niceness value is something that the Linux kernel scheduler will use for determining what should be the actual priority of the process. The actual priority is allocated by the kernel. How should it be prioritized? That is determined by the niceness value. The next field over here which we have is called as vert. Vert is simply virtual memory. So you might have heard of something called as swap memory, right? So that is basically your virtual memory which is allocated to that particular process. And I believe that this is referred to in megabytes, so MBs. Next is RES. Res is just the physical memory which is allocated. If you look at how the internals of a system work, you usually have some sort of shared memory as well. So multiple processes can be sharing the same small pool of memory, right? So that is what the shared tab shows you. Then CPU and memory tab are quite self-explanatory. The time, again, the time just shows what is the CPU time that is needed for that particular process. And then the command just tells us what the actual process name is. So over here, it's something like systemd, it's agent y, something like login, and others. Now over here, there are very limited processes. Why? Because I am running in WSL2, first of all. And second thing is, I am running only a terminal. I don't have any kind of a desktop environment such as GNOME. If you install some kind of desktop environment like GNOME or KDE Plasma or something else, then those things usually create their own processes for running everything that they have. Now they could have some sort of a notification daemon. That is its own process. They will have something to manage all your windows. That is its own process. So that creates a lot more processes. Now, if you're on a Linux system right now, a native Linux system, I encourage you to go ahead and type top in your terminal right now, and you'll be able to take a look at all of those processes. Alright, so in case you don't like the user interface of top, because let's be honest, it's quite bland, it's just black and white. There is a different version of top called as htop. Now, by default, htop is not installed in your system. So, we've already talked about how you can install applications using the package manager. So go ahead and use your own package manager to install htop if you like to visualize your processes in a pretty way. So I can go ahead and do a sudo apt install htop, and I'll get htop installed. Alright, so now I have htop installed, and let me go ahead and run it. As you can see, it's showing you pretty much the exact same thing as top, but this has a prettier user interface, and you have the options to give it some sort of commands from htop itself. So you don't have to exit out of top, and then if you want to kill a process, do kill the particular ID. You can do it right from here itself. Now I want to go ahead and show you how you can kill a particular process. Now killing a process simply means getting rid of that process for good. Right now in this system, pretty much all of the processes which I'm running are very essential. So I would encourage you not to kill the processes which I'm about to show you. The only reason I'm killing them is because in my current session, I really do not need them. And even if I mess something up, all I need to do is restart my WSL instance. But if you're running a native Linux system, I would encourage you to not kill this sd-pam process, because that is what handles your authentication. All I need for killing it is its process ID. So it's called as 179. Let me first go ahead and view it using the ps command. So ps 179. So here it's telling me that this is my process 179, which is my sd-pam, right? Now I want to kill this process. So I can simply do a kill 179. And there, the process is gone. How do I know it? I can once again do a ps 179, and I don't get any sort of a process. Now that's how I know that I've killed that process. But again, I already mentioned that PAM is something that handles your authentication mechanisms. So I strongly recommend you do not go and kill something so crucial. If you're running a native Linux system, then go ahead and open a couple of Chrome tabs and go ahead and kill the Chrome process. That's not going to have a very detrimental effect on your OS. And if you do mess something up, all you need to do is restart your PC and you're good to go. Alright, so that was a brief overview of what the Linux processes are. Now, I also told you that I would be touching a little bit upon the actual mechanism which is used for controlling this Linux processes. Now, you might have seen this within the process tables which I showed you before, but you have something called as systemd within Linux. Systemd simply handles how your processes are created, how much memory should be allocated to a process, handling the priorities of your process, and handling it through the niceness values. All of these tasks are handled by the systemd. Systemd is a really crucial component of Linux. And yes, there are some alternatives, but they are not as good as systemd. Almost all the applications which you see today, they have all been designed with systemd in mind. So I'll be making a completely separate video talking about systemd, what it does, and all of the things which you can do using systemd. But for now, all you need to understand is processes are handled by systemd. Everything, all the manipulations of processes which you want to do, whether you want to edit their priorities, you want to kill a process, all of that is done through systemd. Alright, so we've pretty much covered everything that we needed to about processes, process management, and I also told you a little bit about systemd. Now, if you like this video, please go ahead and click the like button and subscribe to my channel as well. And yeah, I'm trying to release this content every single week, so you have something new to learn every single week. Feel free to join the NoriHub Discord server as well if you have any problems with trying out everything which we mentioned in this video. And yeah, see you all in the next video.